Okay, so here we have a power series, which is centered at 1. And we're asked to find the interval of convergence. So that's all values of x for which the series is convergent. So first of all, let's compute the radius of convergence, which we're going to do by the ratio test. So I have to take the limit when n goes to infinity of the next term in absolute value. So replace every n with an n plus 1. So here we get n plus 1 factorial. X minus 1 to n plus 1. And I put an absolute value here because I don't know if x is positive or negative. And then here e to the n plus 1. Then I should divide by this term, but since this is a fraction, that's the same as multiplying times the reciprocal, so I'm going to do that directly. And I'm going to get e to the n over n factorial, and then absolute value x minus 1 to the n. Again, I only need absolute value where the x is, because these terms are positive already. Okay, now I have to compute this limit. But before doing that, let's simplify whatever we can. So exponentials, I'm left with e. Same for these. I can cancel this and this. I'm left with x plus 1. And then the factorials also simplify. Remember, n plus 1 factorial is n plus 1 times n factorial. That's because this is multiplying all the first n plus 1 terms. So that's going to be the same as multiplying all the first n terms and then multiplying times n plus 1. But this trick allows us to simplify here. So this is n plus 1 times n factorial. Here we are just left with x minus 1. This is cancelled. Here we are left with e, and here we are left with n factorial. So now we can cancel these two. And finally, have our simplified expression. So now, when n goes to infinity, n is only the numerator, so this quantity is going to go to infinity. For all values of x, except when x is equal to 1. When x is equal to 1, then this is 0, so the limit is just 0. But in general, this is positive infinity if x is different than 1. So what does this mean? Well, positive infinity is always greater than 1, right? So the ratio test tells us that this series is divergent for any value of x that's not 1. And remember, 1 is the center, so a power series is always convergent at its center, because then every term is 0. But for no other value of x, this is convergent, which means the radius of convergence is 0. And 1 is the only point at which the series converges. So that's also the interval of convergence. We don't have to do anything else. I mean, it's just a point, the point x equals 1.